All right, students, in our continuing discussion of nerve physiology and action potentials and generation of action potentials, I want to talk about two important concepts, threshold and this all or none response. One thing I had mentioned earlier is that in order for a neuron, we call it a neuron to fire. In order for a neuron to create this action potential, to create this electrical impulse, we have to bring the electrical voltage of the neuron from rest up to what is called a threshold voltage. What brings a neuron from rest up to a threshold voltage are graded potentials. And graded potentials are very small changes in electrical voltage that are caused by neurotransmitters binding to the neurotransmitter receptors on the dendrites in the cell body of a neuron. And so a neuron here is at rest. As neurotransmitters start to bind to that neuron, those neurotransmitters can cause EPSPs, excitatory postsynaptic potentials, graded potentials, small changes in voltage, and as more and more neurotransmitters bind, they cause more and more of these graded potentials, these small electrical changes. And if enough neurotransmitters bind to create enough of these small graded potentials, these small EPSPs, to reach threshold, once I reach threshold, boom, I create an action potential. And once the action potential is created, it will travel all the way down the axon to the axon terminals to cause the release of neurotransmitters at the axon terminals, which will then, those neurotransmitters can then stimulate the next neuron in the chain. So this threshold is, this is the voltage that a neuron has to be stimulated to by neurotransmitters binding to neurotransmitter receptors to actually create the action potential to cause the neuron to fire, to cause the neuron to create an electrical impulse. Now, another thing about those action potentials is once I create the action potentials, first of all, they are always exactly the same size. And if once I create one, that action potential always travels all the way down the axon. And that's called the all or none phenomenon. The action potentials that are created are always exactly the same size, and they always travel all the way down the axon. Now, so how do we vary the signal? How do we change the signal? Well, we don't change the height, we don't change the amplitude, we don't change the magnitude of the action potential, but what we can do is we can change the frequency of the action potential. And so in this case, here I've got a stimulus, and the stimulus has not caused the neuron to reach threshold, and I have no action potentials. Here I have a weak stimulus, but it's enough of a stimulus that I've reached the threshold voltage, and I create a certain frequency of action potentials. If I increase the strength of the stimulus, I increase the frequency and the number of the action potentials. And this is how neurons this is how we can change the signal, how we can change the information that neurons are delivering. So if perhaps that a neuron we're delivering a signal to the muscles to contract very weakly, then I would just have a few action potentials going. But say I wanted a stimulus where I really wanted the neurons to really cause the muscle to contract really hard. In that case, I would increase the frequency of the action potentials. So by changing the frequency of the action potentials, that changes the information. That gives the nervous system information about the strength of the stimulus. Thank you.